Hello everyone, in this today video, I am going to talk about inferential statistics. So let us understand what do you mean by inferential statistics. In this type of test, we take a random sample of data from a population in order to derive some conclusion about the population. Now, let us decode it in a simple manner. Suppose that the average population of a town is 100,000 people. Now what we want to do, we want to check their average monthly income. So if we do survey on 100,000 people, it will be very tedious, right? So what we will do, instead of doing survey on a 1 lakh people, we will do survey on a 10,000 people, basically a sample. And from the sample, we find out that the average monthly income of a person is around 50,000 rupees. So we can say that the average monthly income of the whole population is around 50,000 rupees. So this is called as inferential statistics. Now, inferential statistics is of two types. First of all, we have something called as parametric test, and the second one we have something called as non-parametric test. Now let us understand one by one. In parametric test, we make an assumption about the population like the data should be normally distributed. Whereas in non-parametric test, we don't make any assumption about the population. Now, in parametric test, we have various types of tests available to us. Some of them are t-test, z-test, f-test, a/b test, and Anova test. Now, we will talk each one by one. So first of all, let us understand what do you mean by t-test. T-test, also called as student t-test or Welch t-test. It is used when the size of the sample is very small and you can calculate it using this formula. Now t equal to x bar minus mu naught divided by s upon root n. Here x bar is your sample mean, mu naught is your population mean, s is your standard deviation, and root n is your number of samples. Now let us understand this thing in a very simple manner. Suppose that a question is given to us. Here we have a sample of 10 students and we want to test whether their average score on a math test is significantly different from 75 or not. Now the first thing that we are going to do in this, we will write our null hypothesis and alternate hypothesis. So our null hypothesis will be like this. Scores are not significantly different from 75. Then we write our alternate hypothesis. Here, scores are significantly different from 75. So this is our first step. Once this step is done, the next step is to calculate the mean. So what we do? We calculate the mean of the 10 student and we find out that our value is 78.3. After that, what we will do, we will calculate our standard deviation. So, we will take each sample and we will subtract from the mean. So, you can see, we will taking each sample and subtracting it from mean. After that, we are squaring it out. So, we get a list of values. After that, what we do, we sum all these values and then divide it by n minus 1. So our sample standard deviation will be 4.19. Next, what we will do, we will use all these values and calculate our t statistics. So our sample mean is 78.3. Population mean is already given to us, which is 75. S is we have calculated. Standard deviation is basically 4.19. N is basically sample size, which is 10. So our calculated t value will be 2.5. So this is our fourth step. The fifth step will be is to determine our critical t value. So in order to determine critical t value, we need two things. First of all, we need something called as level of significance. So whenever the level of significance is not given in your question, we assume that 5% will be the level of significance, which is 0.05. And degree of freedom is n minus 1. So number of sample is 10. 10 minus 1 will be 9. Now what we will do, we will look at the t table and find our t value. So if you see the table, here 0.05 is the level of significance and 9 is the degree of reduction. So our t value is 1.833. So here we see that our calculated t value is 2.5 and our critical t value is 1.833. So if the calculated t value is greater than critical t value, we accept our alternate hypothesis and reject our null hypothesis. So here in this question, we accept the alternate hypothesis, which is average math score of 10 students is significantly different from 75. Let us talk about the implementation of t-test. So first of all, this is my question and I am going to write my null and alternate hypothesis. So here the null hypothesis is there is no significant difference in the mean fare paid by passenger who survived and those who did not survive. Similarly, my alternate hypothesis will be there is a significant difference in the mean fare paid by passenger who survived and those who did not. Now, in order to implement the t-test, first of all, what you have to do, you have to import one library which is called as stats library. So from SciPy, import stats module. Next, it will give two things. So first thing it will give is t statistics, and the second variable that I'm going to use is p value. Then I'm going to use stats.t-test. So I'm writing stats.t-test underscore ind. Then here I am going to specify the fare of the passenger who survived. So I am going to write df survived equal to 1 fare. After that, I am going to write it for the passenger who do not survived. So let me copy this out. Once this thing is done, let me run this out. We will be going to print our t statistics value and p value. So this is my t statistics value and this is going to my p value. Now here we can see my p value is less than 0.05. It means we can accept our alternate hypothesis and reject our null hypothesis. So you can write this thing in Python also. You just write if p value less than 0.05, alternate hypothesis is accepted, else null hypothesis will be accepted. So this is my t-test implementation. Now let us talk about z-test. Z-test is also known as large sample t-test. So the formula for z-test is x bar minus mu divided by sigma upon root n. Here x bar is your sample mean, mu is your population mean, sigma is your population standard deviation and n is your sample size. Let us understand this thing with the help of an mathematical example. In this question, a manufacturer claims that average life of a certain types of battery is 300 hours. A consumer group tests 50 batteries and finds that their average life is 290 hours with a standard deviation of 40 hours. Can we conclude at a 0.05 significance level that the true mean battery life is different from 300 hours? So this is the question that we need to solve. So the first thing that we have to do is we have to assume our null and alternate hypothesis. So the null hypothesis will be average battery life is 300 hour and the alternate hypothesis will be it is not 300 hour. Next, we will be going to calculate the z value. So this is my formula and these are all the values given to us, which is simple mean is 290, mu is 300, the standard deviation is 40 and the number of sample sizes 50. Now we put all this value into the formula and we get the z value as minus 1.77. Now this is our z value. Next, what we will be going to do, we will be going to look for the value in the g table at a 0.05 significance level. So we can see that at 0.05 significance level and here the z value is minus 1.7. So the value here comes out to be 0.04, which is less than the significance level of 0.05. So we can say that here we reject our null hypothesis and accept our alternate hypothesis. Means the average battery life is not equal to 300 hours. Next, I am going to talk about g-test practical. So here my null hypothesis is the mean fare of the sample is equal to 32 and the alternate hypothesis is mean fare of the sample is not equal to 32. So first of all, in order to implement this thing, what I am going to do, I am going to import the libraries. So from stats model dot stats dot weight stats import z-test. It will return two things. So first thing it will return is z statistics. Second is p-value. Now I will call g-test on the fare. So here I will write df of fare. And I want to check with the value as 32. Value equal to 32. Let me run this out. Here we have done one spelling error. So basically here we have to capital F. Now it's done. After that I am going to print my g statistics value and p value. So here we can see my p value is greater than 0.05. It means the null hypothesis is accepted, alternate will be rejected. So let me write it out in Python. Here we can see null hypothesis is accepted. So this is the practical of z-test. Next, let us talk about f-test. F-test is also known as variance ratio test. It is used for comparing the variance between the two samples. Let us understand with the help of an mathematical example. So, a factory produces metal rod and the manufacturer claims that the variance of rod length is 4 cm square. We collect a sample of 10 rods and measure their length. So this is my question. Now what the first step will be is to make our null and alternate hypothesis. So my null hypothesis will be there is no significant difference in the variance and my alternate hypothesis will be there will be significant difference in the variance. Once we decide our null and alternate hypothesis, the next step is to calculate our sample mean, which is 10.5. After that, we will be going to calculate our sample variance with the help of this formula. Sample variance equal to summation of xi minus sample mean whole square divided by n minus 1. So when we put all these values into the formula, we get that our sample variance is equal to 2.5. Now, we will be going to calculate our F statistics with the help of this formula. Sample variance divided by U sigma. Then our F statistics value will be 0.625. Next, what we have to do, we have to calculate our degree of freedom. So we already know that degree of freedom is n minus 1. So 10 minus 1 is 9. So my degree of freedom will be 9 here, and for df2 the value will be infinity. Now we'll look for these values in a F table. So here we can see that df1 is 9 and df2 is infinity. So my value will become 1.88. So it can see that the 0.625 is less than 1.88. It means we do not reject our null hypothesis, means there is no significant difference in the variance. So this is all about F-test. Next, let us perform the practical on F-test. So here my null hypothesis will be there is no significant difference in the mean fare between the passenger who survived and those who did not survive. Alternate hypothesis will be there is a significant difference in the mean fare between passenger who survived and those who did not. So let us implement this practical. So here I am going to initialize two variables. The first variable name as F statistics. Second is my P value. And here I am going to call my stats module, and then we are going to perform one way F test. So I am writing F one way. Then I am going to write my passenger who are survived. So df survived equal to 1. Fare. Similarly, the fare of the passenger who did not survive. Now let me run this out. Now let me print my F statistics value and print my P value. So here my P value is basically less than 0.05. So we can say that null hypothesis is rejected, alternate hypothesis will be accepted. So this is all about F test. Next, let us talk about analysis of variance, also known as Anova. It is used when all the explanatory variables are categorical in nature. Let us understand this thing with the help of a mathematical example. Here, data is given for the two students. So this is the performance score of student A and this is the performance score of student B. The question is this: we want to test whether the two student mean are same or not. In other words, does the student type affect the performance of students? So to solve this problem, what we do, first of all, we assume our null and alternate hypothesis. So my null hypothesis will be there is no significant difference between mean of student A and B. Alternate will be there is a significant difference between mean of student A and student B. So now let us start solving. So first of all, what we are going to do, we are going to calculate the mean of both the student, which is student A and student B. So the mean of student A is 3 and the mean of student B is 5. Next, I am going to calculate overall mean, which is going to be 4. After that, we are going to calculate total sum of square. So the formula to calculate total sum of square is summation xij minus x of total whole square. So this is how you can calculate total sum of square. Now we put all the corresponding values into that. For example, 3 minus 4, then 4 minus 4 and so on, and we get our result as 44. So this is our total sum of square. Next, I am going to compute something called as between group sum of square. So the formula to calculate is this, which is NA, number of student in A, XA minus X total whole square plus number of student in B, XB minus X total whole square. So the between group sum of square result will be going to be 20. After that, I am going to calculate within group sum of square, which is basically SST minus SSB, which is 44 minus 20. The result will be 24. After this, what I am going to do, I am going to compute the degree of freedom. So the overall samples we have is 20. So 20 minus 1 equal to 19. Next, I am going to calculate between groups degree of freedom, which is k minus 1. So 2 minus 1 equal to 1. Here the k is your 2 students. Within groups degree of freedom is n minus k, which is 20 minus 2, 18. After that, I am going to compute mean square. So mean square between, which is SSB divided by df of between, which is going to be 20, and mean square within, SSW divided by degree of freedom within, which is going to be 1.33. Once we have calculated all these steps, the next step is to find out our F statistics value. So the F statistics formula is F equal to mean square between divided by mean square within, which is going to be 15.04. We are going to compute something called as critical value. So here, with the help of an F table, our degree of freedom for first one is 1 and degree of freedom for the second one is 18 at a alpha of 0.05. So here the critical value will be 4.41. This value is come up from your F table. Now here we can see if the calculated F value is less than tabulated F value, then null hypothesis will be accepted. And if the calculated F value is greater than tabulated F value, then alternate hypothesis will be accepted. In our case, 50.04 is greater than 4.41. So we can say that our alternate hypothesis will be accepted and the null will be rejected. Means there is a statistically significant difference between mean of student A and student B. Now let us see the practical of Anova test. Anova stands for analysis of variance. We already know that. So in this question, what we are trying to solve, we want to check whether there is a significant difference in the mean fare among 3 passenger class. So the null hypothesis will be there is no significant difference in the mean fare among 3 passenger class. And the alternate hypothesis will be at least one passenger class has a significantly different mean compared to other. So this is my analysis of variance. So here I am going to initialize a variable. Let us say the variable name is Anova. Then I am going to call my stats module. Then here I am going to apply one-way Anova. So first of all, I want to check the fare of passenger class 1. So I will write df of P class equal to 1 fare. Similarly, I will write for passenger class 2 and passenger class 3 also. Now let me check the Anova value. So this is my Anova value. Now from this value, I want to retrieve the P value. So I'll write Anova dot P value. So here we can see my P value is less than 0.05. Next, what we are going to do, we are going to compare it with our significance label, which is 0.05. So here the P value is less than 0.05. So alternate hypothesis will be accepted and the null will be rejected in this case. So we can say that at least one passenger class has a significantly different mean compared to the others. Let us talk about non-parametric test. In non-parametric test, we don't make any assumptions about the parameter for the given population. If you remember, in the parametric test, we make assumption about the parameters, like the data should be normally distributed. Whereas in non-parametric test, it is applicable for both types of data, whether the data is normally distributed or non-normally distributed. That's why this test is also called as distribution-free test. There are two types of parametric test. First one we have is chi-square test and the second one we have KS test. Let us understand each one by one in a great detail. Chi-square test is used to find out the association between two or more categorical variables in the same population. It was developed by a person named as Carl Pearson. It is also known as goodness of fit, and you can calculate the chi-square with the help of the below formula. Now here we can see the chi-square formula is equal to summation I equal to 1 to n observed minus expected frequency whole square divided by expected frequency. Now the question here is, how do you calculate expected frequency? So in order to calculate expected frequency, we have a formula given to us which is row total multiplied by column total divided by grand total. Suppose that in a social media campaign, we are going to use two strategies. One is your old strategy and one is your new strategy. To increase the brand awareness, the effectiveness of strategy 1 or old strategy in increasing the brand awareness. So in order to solve this question, first of all, what I am going to do, I am going to make our null and alternate hypothesis. So null hypothesis will be there is no association between strategy 1 and increased brand awareness, and here the alternate hypothesis will be there is an association between strategy 1 and increased brand awareness. Now what we will do? We will be going to calculate expected frequencies from this. So this is my formula. Let us calculate for each cell. So first of all, I am going to calculate it for used strategy 1, which is awareness of the brand. So first of all, row total. So my row total will be 400 multiplied by column total, which is going to be 2001. And we will divide by grand total, which is also 2000. So the values will be 400. Similarly, we repeat for all the other methods. So this is for strategy 1, which is for not awareness. So 400 multiplied by 1000, 800 plus 200 and divided by 2000. Then here also, then here also. So this is how you can compute the expected frequencies for each block. Once we get our observed frequencies, once we get our expected frequencies, now what we do, we put them into the formula of chi-square. So chi-square is equals to observed minus expected ka whole square divided by expected. So for each cell, we are going to calculate our chi-square value. After that, we are going to add up together, and my calculated chi-square value is 67.19. Next, what I am going to do, I am going to calculate our degree of freedom, which is n minus 1, rows minus 1 multiplied by column minus 1. So the value will be 1. So using the chi-square table at a 0.05 significance level, the critical chi-square value will be 3.841. So here we can see that 67.19 is greater than 3.841. It means we can reject our null hypothesis and accept our alternate hypothesis. Now let us talk about the practical of chi-square test. So chi-square test help us to find the relationship between two categorical variable. So here my null hypothesis will be there is no association between passenger class and the survival, and the alternate hypothesis will be there is a relationship between passenger class and survival column. So first of all, I am going to import one library which is stats. So from SciPy imports stats module. Next, I am going to create a tabulated figure with the help of pandas.crosstab. So let me create my observed table first of all, pd.crosstab. So here my first column will be survive, passenger class and survive, and I will print my table. So this is my tabulated figure. So here, first of all, I am going to use 4 variable. So the first variable name is chi-square statistics. Second variable name is p-value. Then there will be third variable which is empty. And there is one more variable which is empty. Then I am going to call my stats module and call the chi2 contingency function. Here I will pass my observed data. Let me run this out. Now let me print my chi-square statistics value and my p-value. Now you can see my p-value is less than 0.05. It means alternate hypothesis is accepted and the null will be rejected. So let me code this out. So this is all about chi-square test. Now let us talk about KS test. KS test, also known as Kolmogorov-Smirnov test. It is used for checking whether your column is having normal distribution or not. Now let us do this thing mathematically. So here is one of the example we have. In a company there are 6 products, which is app 1 to app 6, and the number of people who uses the product. Now the total sum of the users is 240. Now we have to check whether the distribution of app uses is having normal or not. So my null hypothesis will be that they are having a normal distribution, and my alternate hypothesis will be that they do not have any normal distribution. So this is my table. The observed value will be given to us, and the expected value is for all of them it is going to be, which is overall 240. Now we are going to calculate S of x, which is each value divided by 240, and F naught x, which is each value, expected value divided by 240. After that we are going to calculate this out, and we getting our end result as 0.079. Now we know that the number of samples given to us is 6 and the alpha is 0.05. The critical value we can get it from the table is going to be 0.521. If you compare both those values, we can see that our critical value is greater than the calculated value. So we can say that our null hypothesis will be accepted, means the data follows a normal distribution. Next, let us see the practical of KS test. So we have studied that KS test is used for checking whether the numerical variable follows a normal distribution or not. So here in this question, what we are doing, there is a null hypothesis and alternate hypothesis. So I am going to initialize 2 variables here, KS statistics and the p-value. Then I am going to call stats.ks test, and here I am going to pass my numerical column, which is fair. And we want to check whether this column is having normal distribution or not. So let me run this out. Now let me print my p-value and my KS stat. So here we can see that my p-value is 0.0, which is lower than 0.05. So we can say that my alternate hypothesis is accepted and the null hypothesis will be rejected. So in this question, the fair variable does not follow a normal distribution. So this is all about KS test.